Bismillah, Alhamdulillah, wassalatu wassalamu ala Rasulillah. This is Math 111 major exam 2, the second major examination, term 232. Let us have a look to the exam and solve it together. The first question, given that f of x equals square root of x plus 1, find f prime of 3. Well, there is a definition how to find f prime of a. It is the limit when x approaches a, f of x minus f of a over x minus a. There is also another definition, but I'm going to use this one. So a in this case is 3, and f of x is square root of x plus 1. So he is asking me to find f prime of 3. It would be the limit when x approaches a, which is 3, f of x, which is square root of x plus 1, minus f of a, which is f of 3. Now let us find f of 3. F of 3 would be square root of 3 plus 1. I replace x by 3, and that's square root of 4, which is 2, so I have 2 here, and I have x minus a, which is 3, so this is the limit. Now how to find the limit? I replace x by 3, so this would be square root of 4, which is 2. 2 minus 2, 0. 3 minus 3, 0. So it would be 0 over 0. When the limit is 0 over 0, we should either multiply by the conjugate if we have root like this, or try to factor. Well, here I need to multiply by the conjugate because I have square root. So I multiply by square root of x plus 1 plus 2, up and down. So this is just 1. I didn't change anything in the limit. So I have limit when x approaches 3. Now how to multiply two fractions? Multiply the numerators. So square root of x plus 1 times square root of x plus 1, I'll have x plus 1 minus 2 times 2, that's 4. This is how to multiply x minus y times x plus y. You get x squared minus y squared. That's a famous formula. Now x minus 3 should be multiplied by square root of x plus 1 plus 2, but I'll keep them like this. Now x minus 1 minus 4 is negative 3. So I'll have x minus 3 up, and I already have x minus 3 down, and that's why I didn't multiply in the denominator. So I can cancel this with this. X goes to 3. After canceling, I can replace now x by 3. So I have 1 up because this is cancelled, so I still have 1. And square root of 3 plus 1, which is 4, square root of 4 is 2 plus 2. So the answer is 1 over 4. Let me solve it by the other way. The other way says that f prime of 3 is limit when h approaches 0, f of x plus h. So the other formula, f prime of a is limit h approaches 0, f of a plus h minus f of a over h. So now I need to find f prime of 3. So I need f of 3 plus h. How to find f of 3 plus h? You go here, I have f of x, and I replace x by 3 plus h. So I'll have square root of 3 plus h plus 1. That would be 4 plus h minus f of 3, which is, as we found here, 2 over h. And again, you need to multiply by the conjugate, because if you replace h by 0, you will get 0 over 0. So 4 plus h plus 2 over square root of 4 plus h plus 2. Now, again, multiplying, I'll have 4 plus h minus 4 over h times square root of 4 plus h plus 2. And now 4 cancels with 4. And after 4 cancels with 4, I'll have h up and h down, so I can cancel them together. And then I replace h by 0, so I have 1 up, and square root of 4 is 2 plus 2. It's also 4. So both methods are similar in difficulty, and you can use any one of them to find f prime of 3. Differentiate the following functions. Well, the derivative is pi is a number, so pi to the power 7 is a number, so its derivative is 0. So you can write 0 plus, or you can just leave it. And the derivative of e, this is e to the power u. Well, e to the power u derivative is e to the power u times u prime by chain rule. So the derivative would be e to the power negative x cubed plus 15 times the derivative of u, which is the derivative of x cubed is 3x squared. 3 times negative 2, that's negative 6, x to the power 2, and derivative of 15 is 0. So the final answer is negative 6x squared times e to the power negative 2x cubed plus 15. That's the derivative. Here I have a quotient, so I will use the quotient rule. So y prime is, the quotient rule says that derivative of f over g is g squared in the denominator, then derivative of f times g minus f times the derivative of g. So what is in the denominator, you square it. So I have tanh, hyperbolic tan or tanh. I just square it. So that's what is in the denominator. And now the derivative of the numerator, which is 1 over 2 square root of x. That's the derivative of square root of x. Times the denominator, which is tanh x. So this is f prime times g minus f square root of x times the derivative of tanh. Well, derivative of tanh is hyperbolic secant square. So this is the final answer. You can just leave it like this. Verify this identity. This is from section 3.11, and to verify the identity, I need the definition of hyperbolic sine, sinh x. Well, the definition is e to the power x minus e to the power negative x over 2. That's the definition of hyperbolic sine. So if I start with the left-hand side here, I'll have, now instead of x, I have lnx. So I should replace x in this definition by lnx. So I'll have e to the power lnx minus e to the power negative lnx over 2. Now I have a formula that says, there is another function here. Okay, I'll finish this and go back to it. We know that e to the power ln x is x. Ln cancels e. So I'll have x here. But here the cancellation doesn't work because I have a negative sign. But I know that whenever I have ln ur, it is r ln u. So this r, if I need, I can bring it up as a power of u. So this minus, I can bring it up as a power of x over, and there is an e, of course, over 2. And now this e cancels the ln because of this formula, and I have x minus x to the power negative 1 over 2. I can simplify this more by writing x to the power minus 1 as 1 over x over 2. And now to simplify this, I can multiply by x over x. So x times x would be x squared. X times 1 over x will be cancelled and I'll have 1. And in the denominator, I have 2 times x. Remember, whenever you have two fractions, how to multiply two fractions? You multiply a times c up and b times d down. He needs the derivative of tan inverse u. Well, tan inverse u, the derivative is 1 over 1 plus u squared times u prime. That's the derivative of tan inverse u. That's the formula. So y prime would be equal to 1 over 1 plus. This is u now, x to the power 8. I have to square it. So when I raise x to the power 8 to the power 2, I multiply the powers and it would be x to the power 16. And then times the derivative of x to the power 8, which is just 8x to the power 7. I can write it up here if you like, 8x to the power 7, or you can write it here times 8x to the power 7. So that's the answer. For this curve, find the tangent line to the curve at the point 0, 0. Well, the tangent line has the equation y minus y0 equals f prime or y prime, because I have y here, at x0 times x minus x0. Well, this is x0 and this is y0. So the equation would be y minus y0, which is 0, equals y prime at 0, which is this one, times x minus x0, which is 0. So that's the equation, and all I need to find is y prime at 0. To find y prime at 0, I need to find y prime itself. So y prime, I have len. This is len u. The derivative of len u is 1 over u times u prime. That's a formula. So y prime would be derivative of len. This is u. So derivative would be 1 over e to the power x minus x to the power 11. And then times u prime. I can multiply u prime here, or I write it up in the numerator. So the definition of ex is ex. And the definition of x to the power 11 is 11x to the power 11 minus 1, which is 10. So to find y prime at 0, I replace x by 0. E to the power 0 is 1. And x, if you replace it by 0, it would be 0. E to the power 0 is 1. And x to the 0 to the power 11 is 0. So the answer is 1. So the equation is y equals 1 times x, or just x. So this is the equation of the tangent line. Use implicit differentiation to find dy by dx. Well, we have to use implicit differentiation because we have the equation is not solved for y. We have y and x in the same equation. So how to find the derivative? We find the derivative as usual, but with respect to x. So this is a product. Derivative of the first term, which is x. Derivative of x is 1 times x prime dx by dx, which is 1. So derivative of x is 1 times y plus. I don't have to write 1 plus x times derivative of y. If the equation is solved for y, so what would be the derivative of y? You will write y prime, isn't it? Look here. So it was y equals, the first thing you wrote, y prime. So implicit means similar to the usual derivative. Whenever you have y and find its derivative, don't forget to write y prime. So derivative of y is y prime. So this is the derivative of the left-hand side, equals. And something came to my mind. Verify. Yeah, here x squared minus 1 over 2x, I'll just need to write equals right-hand side. This is the right-hand side. Now, derivative of sine x, cosine x, that's known. But derivative of cosine y, there is a difference between x and y because we find dy by dx. Derivative of 4 cosine y, 4 is a constant. Derivative of cosine is negative sine. So I'm going to write negative here, make it negative because of the negative coming now. And derivative of cosine, negative sine y, but this is y, so I need to multiply by y prime. So now how to solve the equation for y prime? Y prime is dy by dx. Well, all terms with y prime, you have to keep them in one side. So I have xy prime in the left-hand side, and I'll take this term to the other side. So I will write it plus because it's minus 4, and I will write y prime first times sine y, and then equals. Now in the right-hand side, I have y, which was here. If I bring it to the right, it would be negative y, and I have plus cosine x. So from the two terms in the left-hand side, I can take y prime as a common factor. So I'll have x plus 4 sine y, and I have here negative y plus cosine x. And finally, I can find y prime by dividing both sides by x plus 4 sine y. So this would be 1 cancels, y prime would be equal to, and this side would be negative y plus cosine x. So this would be the answer. Find this limit. Well, there are formulas about limits sine x over x, and so we know that limit sine x over x, when x approaches 0, we know that the limit is 1. And limit 1 minus cosine x over x when x is 0, also this is equal to 0. So this is a formula. These are two formulas. We have them. So here, what do I have? I have sine x minus cosine x times sine x over x squared. If you replace x by 0, you will get 0 minus 0 over 0, 0 over 0. Also, this is 0 over 0. Also here, 0 over 0. So you need formulas. There is no here multiplying by conjugate or factoring, but notice that I have sine x here and I have cosine sine here. So what if I take sine x as a common factor? So if I take sine x as a common factor, I'll have 1 minus cosine x over x squared. And now, because of this fact, notice that AC over BD, you can write it as A over B times C over D. So I have here sine, I can write this as limit sine x over x, because I have x squared here, times 1 minus cosine x over x. Now, if you multiply these two, you will go back to here. Why I wrote it like this? Because I know the limit of sine x over x and the limit of 1 minus cosine x over x. And the limit distributes, if I have a product, limit of product will be product of the limits. This is a property of the limit, we know it. So this limit is 1, this limit is 0. 1 times 0 is 0, and the limit is 0. Car A, this is car A, is traveling west. This is west at 20 kilometers per hour. So this is the distance car A is traveling, X. We call it X here in the graph. So what is this? What does 20 kilometers per hour represents? That's the speed of the car. And that's kilometer per hour. So that's the change in the distance. The change in x, it is the rate of change of x with respect to time. So in fact, 20 is dx by dt. It's 20 kilometer per hour. Kilometer for x, the distance is by kilometer, and time is per hour in this case. So this is kilometer per hour, kilometer over hour, kilometer over hour. So it has to be a rate of change. Car B, this is car B, is traveling north at 40 kilometer per hour. So again, 40 kilometer per hour is the change of y. Okay, this is the distance car B is traveling. So dy by dt is 40 kilometer per hour. Both are headed for the intersection. Intersection here is C, so they are car A, car B are heading for the intersection of the two roads. At what rate are the cars approaching each other? So the Z here is the distance between the two cars. When the cars move, this distance would be decreasing. This distance would be decreasing. And notice that they will meet at the intersection. He's asking at what rate are the cars approaching each other when car A is 0.3 and car B is 0.2 from the intersection. So what is the rate of change of Z? What is dz by dt? This is at what rate? Rate means derivative dz by dt. The cars approaching each other because z is the distance between them. So this is the change in z with respect to time. When a is 0.3, so x is 0.3, and y is 0.2. So when the distance between car A and the intersection is 0.3, and the distance between car B and the intersection is 0.2. Notice that x, which is the distance between car A and the intersection in this case, is decreasing. When car A moving, the distance x is decreasing. So since it's decreasing, I have to write here negative sign. Not because we are going left. No, because the distance x is decreasing when as car A uh, reaches the intersection C. Also, y is decreasing, although we are going up, but y here, which is the distance between B and the intersection C, is decreasing. So there should be a negative sign here. And also z, the distance between the two cars, when the two cars are moving to the intersection, for the intersection, z is decreasing. So the answer here would be negative. So now this is called related rates. We have three rates, and how can we relate these three rates? So we need to have a relation between the variables that are changing in this question. And the variables are x, y, and z. And from the graph, you have a right triangle. So there is a relation between x, y, and z from Pythagorean theorem. Says that x squared plus y squared equals to z squared, which is the hypotenuse. So I have this relation between x, y, and z. Now I can have a relation between the rates. If I find the derivative of this equation with respect to t, where x, y, and z are functions of t, so the derivative of x squared is 2x times dx by dt, because x is a function of t. So you are finding the derivative of f, okay, t uh, for so using ft inside x. So you use the chain rule. So after finding the derivative of u, you find the derivative of u prime. That's the same concept here. Y squared 2y derivative, but y is a function of t, so we need to use chain rule to find dy by dt. Also z squared, the derivative is 2z, but also we need to multiply by dz, dz by dt, because z is a function of t. I can divide all terms by 2 here. I can cancel the 2 from all the three terms. And now I can replace x by 0.3 because x is 0.3, and dx by dt by negative 20. and y by 0.2 and dy by dt by -40. Now what about z? Well, I don't have z in the question, but in this triangle, or this triangle, when x is 0.3 and y is 0.2, I can find z in this case. Z would be the square root from Pythagorean theorem of 0.3 square plus 0.2 square. Okay, and this would be square root, use the calculator, it would be square root of 13 over 10. So this is square root of 13 over 10 times dz by dt, which is the unknown we need to find. If you multiply the left-hand side, you will have -14. So -14 would be equal to square root of 13 over 10 dz by dt. And then dz by dt would be multiply by 10 over square root of 13 to get rid of this one. So it would be -14 times 10, -140 over square root of 13 kilometer per hour. Or if you approximate, it would be negative 38.8 kilometer per hour. Let me just check this answer, 140 over square root of 13. It's a 3.88. So 140, sorry. 140, I wrote 14. Yeah, good. So the answer is correct. And this was the last question. So I hope you enjoyed solving this exam with me.